Hi everyone, let's go to question number 18. Problem 18 right here. 3x plus 2. All right, so 3x plus 2 equals 11. We've done this so many times, right? We've done this so many times. Can't help it. So let's just try to see this automatically. Would we get an integer solution? Let's try to approach this in a different perspective. Well, will I get an integer? Well, I know that 3x plus 2 already has the remainder 3 times x plus 2, remainder of 2. Okay, so it leaves a remainder of 2 already. But what about 11? Well, 3 times 3 plus 2. Wait a second. So instead of solving the conventional way, because the remainders are same, I can just eliminate those expressions, eliminate these expressions off the hook, and I got 3 times x equals 3 times 3. Okay, so let me somehow do things that are unconventional. We know that x equals 3, but let's just try to think about some kind of argument that will be extra helpful if we move on and use all of these tricks in, like the competition math. So here we go. 3 times x minus 3 times 3 would have been 0, and 3 times x minus 3 would have been 0. Now, imagine you had this expressions out here, okay? They're the same thing. We've been using the distributive property, and here we go. I'm multiplying 3 by something to get 0. Now, is 0 a multiple of 3 though? Well, I would say it is, because if you can find the quotient, we're done. But 0 will be 3 times 0. So, in fact, that's a multiple of 3. We're totally fine with it. But if I multiply a number to some kind of open block, so for instance, I get a picture that looks like 3 times an open block equals 0, well, that open block should be, in fact, 0 for sure, right? So that's the only way of doing it. So in other words, x minus 3 has to be 0. X minus 3 must be 0. So x should have been 3. And that shall be it.